My name is Aslihan Kerç. I am coming from the Turkish Water Institute. And this session we will try to coordinate with my colleague Minora Yonedo. He's a professor from the Kyoto University. And this session is on monitoring emerging pollutants and radionuclides. And I will be giving the first presentation on EDC monitoring study that we have conducted in Istanbul wastewater treatment plants. But as an introduction to this session, I will very briefly go over some of the legislative issues, and it was a very good idea, I think, for the organizers to put two sessions following each other. And in the previous session, we have also seen very similar slides on these legislative issues on different chemicals. As Professor Yamamoto also mentioned, we have over 100 million chemicals that are indexed by the American Chemical Society, and we know that more than 7 million of these chemicals are commercially available, and only around 200,000 of these are inventoried and regulated. If we very briefly can go over some of the regulation examples, we know that in the European Union, the Water Framework Directive is controlling all the water quality standards. And related with these chemical substances, we have priority substances list and specific pollutants. And environmental quality standards are on these hazardous chemicals, and we have some directives under these standards for specific pollutants. Why I have included this here, that European Union is continuously revising these standards. For instance, in 2013, the list of priority substances were updated, and 2 new substances were added to the European Union priority list. And among these, 3 pharmaceuticals are listed as a watch list. So probably in the near future, they will be also in these standards. So this is a continuous process. Whenever we have new pollutants, new chemicals coming up, and we start to monitor them in our waters, and in time, they become standards. So governments should be prepare themselves to regulate these as well and to monitor these and try to look at the options how to treat them in their wastewaters. Very briefly, if you look at the timeline of the European Union Water Framework Directive starting from 2000 and looking beyond, looking to the future, for instance, we have this updated directive in 2013, and by 2015, the governments are required to revise their river basin management plans, and by 2018, they will also need to include these newly identified substances in their management plans as well. And 2021 is the target date for achieving good chemical status for the existing standards. And by 2027, the newly identified substances will also be included in these management plans. Oops. Besides the Water Framework Directive, some other legislations in Europe also call for these emerging compounds, like, as we know, REACH has a part for endocrine disrupting chemicals, and there are regulated for very high concern. If you go to US, we all know that EPA is looking after these new chemical substances, and Resource Conservation and Recovery Act is amending the regulations to include the pharmaceuticals in the regulations as well. And they have a program on unregulated contaminant monitoring for the contaminants suspected to be present in the drinking water. And they are working on contaminant candidate lists, and when new chemicals are arising, these chemicals will be also added to this list. So it is a continuous process, as I have mentioned. We have commercially available new chemicals every day, and in the future, we will have these in our regulations globally. But the problematic part of these standards, as the name also implies, these are emerging pollutants, and we don't have much data, much information about these chemicals. So currently, there is no EPA-approved detection method for many of the listed emerging pollutants, and it is very challenging to establish regulations when relatively little scientific information about the fate and transport of emerging contaminants, as well as effects on the wildlife and humans. So we don't know what are these chemicals, we don't know how to detect them very precisely, and we are not very sure about their effects on the wildlife and humans. So we are trying to find ourselves in a very turbid environment. Some information about what are we doing in my country, in Turkey. We have water pollution control regulations, and these are some of the regulations related with water, on surface water, groundwater quality, and urban wastewater treatment. And currently, we are working on the new water law, compiling all these existing water-related regulations, and new standards on hazardous pollutants, emerging pollutants are in all of these regulations. We don't have a separate chapter for them. And in the new water law, we will be having more detailed information. Before putting this kind of regulations, we are currently running some studies, some projects on hazardous waste pollution control for point source pollution of inland waters. And in another study, we are looking at the intersection between coastal waters and transitional waters. And also, we are concentrating on non-point source pollution as well, including inland, coastal, and transitional waters. So in all of these projects, we are looking at these potential chemical hazardous chemical substances. We are trying to look at their sectoral distributions, and after that, we are trying to implement into our regulations. Now, about the study, case study we have conducted, we have selected endocrine disrupting compounds as our target group. We know that they are present in almost any domestic and industrial wastewater because of vast use of organic chemicals in our modern life. And we know that in the conventional treatment processes, they are reduced to certain extents, but for their total removal, more advanced treatment technologies are needed. It is well established that we have several organics entering the aquatic environment, and they are interfering with the endocrine system. So what is this? We have hormones in our body, and the receptors in our metabolism, they are working together in harmony in the normal situation. So they have their response in our body, so this is the normal case. So what happens when there is a, instead of a hormone, when there is a blocker or a substance that is mimicking the hormone, it is going to the receptor, and now it is forming another thing that has an agonistic effect, and response of the normal functioning of our metabolism is inhibited. So these kind of substances have adverse effects on our health, on our growth, on the reproduction of the organism, so it is affecting the whole aquatic life. When I say endocrine disrupting compounds, it comprises various classes of organic compounds, including steroids, surfactants, pesticides, herbicides, polyaromatic compounds, and organic oxygen compounds. So they are both natural compounds, natural hormones that are released to our wastewaters, and also we have the synthetic ones. So even if you only have just organic domestic wastewater disposal into the water bodies, we are still changing its system. So we are not only on the synthetic chemical side, but normal hormones are endocrine disrupting compounds for the aquatic environments. So municipal wastewater treatment plants are the major sources of EDCs in the riverine environments. Therefore, we need to have more research into fate and behavior of EDCs within the treatment plants, and if we want to minimize their entrance into the environment. So we have conducted a study in Istanbul, treatment plants. We tried to look at what is the fate of these compounds throughout the treatment. So we have selected, so these are the all treatment plants you see in Istanbul, and we have over 13 million of population, so it is a very challenging issue to manage the wastewater in this big city. In the sensitive areas, we have advanced biological treatment system, but when there are currents and deep sea, we have primary treatment followed by deep sea discharge. So the examples that we have selected for this study is Paşaköy, which is close to a drinking water treatment plant, and the process is there advanced biological treatment. And in another one, this is a conventional biological treatment. It is discharging to the Marmara Sea. And the other one, Kadıköy here, it is just physical treatment with followed by deep sea discharge. So we have compared the performance of these plants. Again, to illustrate you the boundaries of these treatment plants, so these are the wastewater collection zones. This Paşaköy with the advanced treatment close to the drinking water reservoir. This is a major drinking water reservoir in Istanbul. And this one is close to the sea with more residential areas. And in this one, in a larger area, a little bit removed from the city, where we have more industry as well. Our focus was mostly on the one which is very close to the drinking water treatment plant. This plant has a capacity of like 100,000 cubic meters per day. And it has A2O process, removing nitrogen and phosphorus, and it also has a scent filter and UV disinfection at the end. How do we determine these endocrine destructing compounds in wastewater? It has various steps. I will, of course, not go over these steps, but just to give you an idea, it has an initial filtration stage, very roughly, and then we go to solid phase extraction, and finally you go to GCMS. So as you see that, unfortunately, this is not a very easy detection. It requires skilled personnel to monitor these, time-consuming, and precision is sometimes very low. Repeatability, you have to work on these standards a lot. So are we going to have these regulations very easily in our drinking water standards? The answer is no. So we cannot expect many people to go over these detailed analysis program and analyze them on a routine basis. So we definitely need more general parameters, like many of the presenters have shown us, like measuring toxicity, estrogenicity. So we need easier programs, easier parameters to follow. But for setting the standards to understand what is the behind, what is the effect of these substances, we need some scientific information and more research before deciding about the correct methodology. So these were the list we have studied in our project. So we both include synthetic hormones and natural hormones as well, and some pesticides. We have run this over a year, over different time periods, and the result was it is very fluctuating. Even within the same city, seasonal variations are there, depending on the quantity of water, the season, rainy season. In the graph, we see influent as blue and the affluents as red. As you can see, for some of them, in the affluent, we still have these hormones a lot. Some of them are totally eliminated in the affluent, but still we are in problem in the affluents. Another example of a different month. So I would like to draw your attention to nonyl phenols. So the alkyl phenols were almost always the highest part, together with the phytosterol, very at the end. Another one. So at the end, we tried to make a comparison between different treatment plants, and phytosterol in most of them were the highest natural hormone we observed, and octyl phenols and nonyl phenols were also seemed to be high in all the treatment plants. Now, if you look at the percent removal rates, this is the one with the advanced biological one. This is the conventional biological, and this is just primary treatment. As expected, the one with the primary treatment has the lower removal rates. So, among 14 EDCs, we have monitored phytosterol, which is a natural occurring plant story. It was the most abundant one in the influent samples for all the plants. And in the second group, relatively high influent concentrations were the alkyl phenols. Nonyl phenol in wastewaters, in domestic wastewaters, is attributed to the degradation of detergents we are using. And alkyl phenols originate mainly from the industries, for example, from the textile industry. As I have mentioned when I showed you the map, the Paşaköy and Tuzla treatment plants have industrial wastewater fractions, while Kadıköy plant was mostly domestic. So observation of higher alkyl phenol levels in those two plants with industrial inputs were something that we were expecting. And also another important industrial, industrial input is bisphenol A. It was very low in the domestic wastewater receiving plant, where it was a little bit higher in the others. And if you compare the steroid hormone levels in these plants, the domestic ones were also higher in several folds in concentration. And for the pesticide levels in all three plants, we did not observe very high concentrations. We don't have so much agricultural fields around this plant, so it was also expected. So, as a conclusion, I can say that source of wastewater, whether it is industry, whether it is only domestic, if we have industrial input, it significantly affects the EDC composition of the all wastewater composition. And as I said also, when we have advanced biological treatment, it also helps for higher removal efficiencies for eliminating the endocrine disrupting compounds. But keep in mind that these chemicals now are transferred into the sludge. Then comes the sludge management issue. What are you going to do with your waste sludge? In our case, the sludge is thermally dried and then sent to cement factories as a fuel supplement. So in our case, we don't have a problem of the release, releasing it back to the environment. But if you have a possibility of leaching of the sludge to the drinking water resource again, then you have to be careful. And although Kadıköy plant, which was only primary treatment, also revealed that we do have some reductions ranging between 50 to 80%. So this demonstrates that non-biological processes are also affecting this removal mechanism. Advanced treatment techniques are becoming inevitable for total elimination of EDCs to achieve better effluent quality. If we want total elimination, if you want zero discharge, the conventional methods are not enough. You have to go for advanced oxidation methods like ozonation, photocatalytic oxidation, and combination of these processes. So, I tried to give you an overview what we have done in our study. So, if you have any questions, I am happy to answer them. I don't know what are we doing in time. Yeah.
Dr. Aslihan, thank you very much. That's a very comprehensive, interesting research. And did you look for the heavy metals also that usually we should look for them in that kind of wastewater? Did you look for them also?
Yeah, in the plant that is receiving industrial wastewaters, we sometimes have heavy metal problems, but this project was mostly on monitoring these organic compounds.
Yeah.
You're right, so the heavy metals is an issue that we have to also follow in the treatment plants.
Yeah, you pointed to because I have in fact, my PhD was on perimetry and this kind of things. You had some, but later you mentioned that you didn't find so much pesticide.
No, because these are not from the agricultural sites.
No, perimetry is they use it most in city.
Yeah.
Is a pest. Home pest control pesticide most.
We didn't have it so much under the deductible limits.
Thank you very much.
Yes, please.
Thank you very much for very nice presentation. But again, the details with regard to these emerging pollutants. But I was just trying to imagine the technical feasibility and economic affordability of the advanced treatment technologies in Africa. How is it expensive to have these kind of technologies? Because I see that could be a very big problem in
unfortunately,
Africa.
yes. So that's why there are lots of research on this one trying to reduce the economical costs. Unfortunately, the advanced oxidation technologies are not feasible yet. So it is important to have source control as much as possible. So before mixing it with our wastewater, dealing with very high quantities of wastewater, point source control should be the first step we have to follow.
And what do you think would be your advice for African countries with regard to emerging pollutants, managing, treating, and all this?
Yeah, as I have illustrated, if you have a good biological treatment, it helps to reduce the levels a lot. But especially if you have industrial chemical inputs, then those industries should treat their wastewater individually before discharging into the total wastewater. So as much as possible, do not mix industrial wastewater with domestic wastewater. Do not increase the volumes.
The comparison between the 3 treatment plants was very revealing. That was a very nice study. With the purely physical plant, you still showed quite a degree of reduction. Do you know what mechanisms cause that in the physical treatment? Is it exposure to light? Is it
the basic sedimentation helps, and also we have aerated grid chambers there in that plant.
I have a couple of questions. First one is, did you measure the alkyl ethoxylate because the nonylphenols, octylphenol, those are the intermediates of the detergent, right? So you need to think about the mass balance of all the compounds in this. You kind of calculated the removal efficiency, but that's just you need to find out how much of ethoxylates are coming in, and also how many of the intermediates are produced in the system. And the second one is, did you check the effect, the concentration of E2 and E2, because those are the concern, and did you check, have you checked about the effect concentration of those kind of compounds with your detected concentration?
Yeah, we did. I have just shown you some examples of the 14 compounds. We have the ethoxylates and E2 concentrations. Yeah, we have a detailed project on that, so this was just an overview. Yes, we know about those ones. Thank you. It's an important part. So when you look at the mass balance and throughout the treatment, so these chemicals change their structure. Yeah.